Welcome to What's Best Forum's Masters and Makers interview series. I'm Ron Resnick. If you enjoy this interview, please kindly click like and subscribe to my What's Best Forum YouTube channel. Today we are meeting Dimitris Baklavas, co-founder and chief designer of Ypsilon Electronics in Athens, Greece. Good evening there, Dimitris.
Good evening.
Tell me about the organization of Ypsilon. How many people do you have working with you?
We are 8 people working in the company. We have another 2 external designers, mainly for CAD and mechanical drawings and 3D renderings. The everyday personnel, we are in total 8.
And does Fanis, your co-founder, work with you full-time?
Yes.
Have you written the schematic for every electronic component yourself?
Yes.
And who physically assembles the components? Who does the soldering? Who does the physical assembly? Are those some of the 8 members that work with you full-time?
Yes, we are a small company. The production area is divided in 2 rooms, let's say, and one is mainly for transformer manufacturing, windings and assembly and termination of transformers. And then we have another procedure of baking the special varnishes and resins used in the power supply transformers. And the other room is the main assembly room, where we do assemble our own boards, and we do the final assembly of the components.
Do you outsource the manufacturing of the cases?
Yes, yes. We design the aluminum parts ourselves. We have another 2 designers that are good in CAD programs. We have outsourced the aluminum parts for the boxes from a few different vendors. Which one is best to each specific part?
On your website, you write, quote, "At Ypsilon Electronics, we strive to reproduce music in a way that is true to the original recording," unquote. But since you are not listening to the mic feed at the original recording, and the only way we can listen to music is by playing it back using a group of components, speakers, electronics, phonos, cartridge, and those all sound different, how do you decide what is true to the original recording?
Our basic aim is to get as close as possible to what the microphone captured, although there are several procedures after the initial recording, of mastering, of processing the recording. But still, there are some details in the signal and in the music that I believe by amplifying these music signals by really transparent electronics, that they don't alter the fine musical nuances and details, the performance can be as believable as possible it can be, even through all these recording processes. For example, you can hear a recording from the 50s, a nice recording of Duke Ellington, mono recordings, or Ella Fitzgerald, and even you can realize the bandwidth limitations, the dynamic range limitations of the equipment of that era. Still, in certain systems and at certain listening sessions I was lucky to be present. It was so believable and so the feeling, so you are there with the performer, that I believe this can happen only by using really musically transparent electronics, and of course the system and the room should be able to allow something like that to happen.
On the website, you also write, quote, "Our achievement is the creation of unique products that communicate to the listener the true meaning of music, emotion," unquote. The idea of true to the recording suggests to me a very neutral, accurate, objective kind of sound, and maximizing emotional connection to the music we love suggests to me perhaps a warmer tonal balance, a more organic or liquid sound. How do you reconcile these two different objectives into one circuit?
It's basically one thing shouldn't fight the other. I believe they are two options of the same coin. I mean that you need all the fine details. You don't need just an organic sound, just a natural sound, but missing a lot of the fine details in the, for example, in a vocal performance or a natural instrument, a natural, for example, a violin or a natural instrument, nuances in the performance. So you need both. You need all the details and you need these details to come through in a natural and free-flowing way in order to achieve a feeling that you are not missing something and you are as close as possible to the original performance and recording.
When a client uses your phono stage for a moving coil cartridge, the audiophile has to use a step-up transformer. Why do you prefer the sound of a step-up transformer rather than using solely tubes to generate all of the required gain?
We use step-up transformers to amplify the signal of a moving coil cartridge, which is usually less than 1/2 of a millivolt. The highest output cartridges might be 0.5 millivolt. Most of them are even less, 0.3. And there is, for example, a particular example that the cartridge is 0.1, 0.12 millivolts, really, really low signal. We use a step-up transformer to amplify this signal, since moving coil cartridges, at one hand, they have low output voltage, but in the other hand, have really low internal impedance. That means that they are good as current generators, so they can drive a transformer that basically the transformer, what it does, it transforms the signal to higher voltage but lower current. So it doesn't amplify energy like an active gain stage that can amplify both current and voltage. I have found so far that with a top-level transformer, both in parts and design and construction, the signal can be with cartridges that can drive properly and can match to these transformers properly, can have a sound that is less mechanical, less processed than an active gain stage. I'm not saying that it's not possible to have an active gain stage that can match the performance of a top-level transformer. It's just that so far I haven't done it and I haven't heard one.
Fair enough. So you believe that the sum of the gain generated by the transformer plus your moving magnet stage sounds better than if you were to try to generate that same amount of gain using only tubes.
Trying to amplify the signal of a moving coil cartridge with tubes, first of all, the noise level would be really high. Even to a level that might be problematic for the listening. A transformer doesn't produce noise like a tube or a solid-state device. It's going to be really hard to design a very low noise tube stage. You will need, for example, several tubes in parallel to reduce the level of the noise. And then the most challenging thing would be microphonics. Tubes are highly microphonic. So this is going to be really hard to get really low microphonics in order not to interfere with the signal. For example, in our phono stage, the VPS 100 and now the MK2 model, we are using in the first stage an assembly with elastomer, and the tubes of the first gain stage are mounted in elastomer in order to reduce microphonics from the tubes and general external noises from the system or from the loudspeakers, for example. I can imagine that going 10 or 20 times lower in level would be really, really hard to design an active gain stage with tubes to amplify the signal and keep microphonics as low as it is in the moving magnet input.
On your phono stage, why don't you offer different cartridge loading options? Do you feel that the ability to change the cartridge loading is not material to the sound?
It is. Sometimes it's needed. We have loading plugs in the step-up transformers. And basically in the large series of transformers, we have a loading plug parallel to the input in the cartridge side and another loading plug parallel to the output of the transformer. So loading the output of the transformer, you can provide some damping not only to the cartridge inductance in itself. This is what actually you do. You are damping slightly the series inductance of the cartridge, but loading at the secondary of the transformer, you are damping also the series inductance of the transformer. This sometimes has a positive effect in some systems, but not always. Depends on the cartridge, depends on the matching transformer, and also depends on the electromechanical system that the cartridge forms with the tone arm. And sometimes loading the cartridge, you not only lower the peak in high frequencies that the most moving coil cartridges might have, you also damp some of the resonances of this system.
On the line stage, you offer both balanced output and single-ended output. Is the balanced output the end of a true differential circuit, or is that balanced output just have a balancing transformer near the XLR connector?
The output of the preamplifier, both the RCA and the XLR are in parallel. So pin 2 is positive and pin 3 is grounded. The output impedance of the preamplifier is really low. In most of the volume output steps is lower than 100 ohms. By using a balanced input amplifier, using an input transformer, you essentially have a balanced line. What defines a connection, if it's balanced or not, are not voltages, are impedances of each leg to ground. So when you have a virtually zero output impedance from the preamp, and then you ground also pin 3 to ground, so you have both impedances virtually zero. Then if your balance input has high common mode rejection, then you have a balanced line, regardless if the signal is, the voltage of the signal is unbalanced or not.
Is it correct that in the passive mode on the preamp preserves absolute polarity, but when the demand for gain rises enough to trigger the active tube circuit, the polarity inverts?
Yes, that's true.
Does that change the sound between purely passive mode and the active mode?
In some systems, it might change the sound for the better or for the worse. Depends on the design of the speaker. For example, when you have a speaker with second order filters, usually the woofer and the tweeter are in phase and the mid-range is inverted. So which polarity in the speaker is the correct one? You don't know. When we were designing the preamplifier, we were designing the output transformer of the active gain stage. we were trying to design output transformers both inverted and non-inverted. Non-inverted transformer, we managed to get the bandwidth of the transformer almost to 200 kilohertz, from 6 hertz to 200 kilohertz without peaks. And that is phenomenal performance for an output transformer in a preamp, especially when it is a step-down transformer and not just a bifilar wound 1-to-1. But when we tried to design an inverted transformer, so the active states in total would be in phase, the performance of the transformer wasn't as good. Not only the measurements, but also the sound of the transformer. So we prefer to stay with the non-inverted transformer and keep the active gain states inverting. If a customer does most of the listening with active, he can try both inverted and non-inverting his speakers and see where he gets a better sound, because it's only in the speaker. Maybe connecting the plus of the amplifier to the plus of the speaker, you get the best sound of the speaker. Maybe not. This is something that during setup, the end user should try to maximize the performance in his system.
I know it is your view that even the highest quality resistors can affect the sound in a negative way, so that you prefer using transformers for attenuation rather than discrete resistor arrays or potentiometers. Why do you think more designers don't use transformers for attenuation of gain rather than fancy resistors?
I don't know. Most of the transformer attenuators you can find off the shelf in the market are small transformers with uncontrolled, let's say, quality from the manufacturer of the equipment. For example, what is the design, what is the core material, how the core material is treated magnetically, how the coils in the transformer are wound, with what wire, what insulation, and all these details. Practically, they don't exist, as you can find real high quality resistors from tadalum to naked foil resistors to any type you wish. But when a transformer is made with absolute care to every small detail, and in my opinion is large enough for the task. For example, the transformer attenuators we are using in our preamp in size look like an output transformer for a small 300B amplifier, for example. They are really, really big. So when these transformers are made with all the right materials and the windings are made with a good design, the sound is much better than resistor arrays with high quality resistors. The other good thing about it is that resistor attenuators are wasting the energy, meaning that the output impedance of the array is high. So you need a buffer stage to lower impedance in order to drive cables, amplifiers, and so on. With the transformer, you can have only one component, and when the transformer is driven from a reasonably low output impedance source component, the output impedance of the transformer attenuator, it gets really, really low, because most of the times we're talking about attenuation of at least 10 or 15 dB. So you can drive your amplifiers, your cables, even if they are long. For example, when you have the preamp on the side and the amplifiers next to the speakers, you can drive them with the transformer attenuator and have only one passive component in the signal path. Of course, we have found that driving large transformers for attenuators sound better than smaller ones. When you have a large transformer, when you drive it in a higher level than the line level, it sounds better. That's why in our preamplifier, the active gain stage and the transformer attenuator are preamp is post attenuated. So we have the active gain stage next to the input, and then at the output, the attenuator.
On the alias amplifier, I know the tube input stage is single-ended. The output stage is solid-state push-pull. Why do you prefer a hybrid design with push-pull solid-state output stage rather than push-pull tube output stage?
Most of the push-pull amplifiers, tube amplifiers, are with pendots, like EL34 or KT88 or the Russian-made KT120, 150, and so on. I don't think there is a real option for me, for my taste, let's say, for the sound of these components, to use any of those tubes. I used to like NOS KT88 tubes, or 6L6 John Phillips, for example. But with these tubes, you get really low power, output power. Then if you need high power to drive an 88, 89 dB speaker, you need to parallel a lot of them. And then this might become another problem, not to mention loss of performance. And the other reason is that using a pendot in the output, you have to devise a way to, a pendot is a current source component. So it needs a feedback to become a voltage source, the amplifier to become a voltage source. So you need to devise special ways to use local feedback in the tube and not overall feedback like Williamson type pendot amplifier. Otherwise, you are losing many things that you are trying to reach using a tube. So in the Alias, the output design uses solid state components, MOSFETs. It uses them in a special way. There is no overall feedback, and the amplifier has low enough output impedance in order to drive real-world speakers, and at the same time keep all the naturalness and the organic sound of the tube input, which does most of the voltage amplification.
For more sensitive loudspeakers, will we ever see a 50-watt or 100-watt all-tube amplifier from Ypsilon?
We had one amplifier like that in Munich. We produced a limited series almost 12 years or more, I think, 10 or 15 years ago. We produced a stereo tube single-ended amplifier, 40 watts per channel, using the GM70 output tube, and it was a 3-gain stage design. That was a limited production amplifier, and recently we managed to get, we kept all these years one of those amplifiers as a reference for the solid state components, hybrid actually components. We modified 2 units and made them monoblocks with parallel single-ended GM70, outputting 70 watts.
Perfect.
Actually more, around 80 watts. We were driving a 91, 92 dB speaker with 4 ohm minimum in Munich, the new Kaiser Minal. And the matching was great. I mean, the amplifier was doing well. But the cost of this amplifier and the effort to produce such an amplifier, playing with 1000 volts in the anode of the tubes, with large power supply transformers, with multiple different power supplies for bias, for heaters. Only the heaters in the GM70 require 60 watts of dissipation in the tube. So it's a real effort to design and build an amplifier like that. We are planning actually to produce a limited production of, again, something like that, a tube single-ended. We built also in 10 years ago a 211 amplifier, a parallel single-ended, actually with equivalent tube to the G211, the Telefunken 237 from the 30s and 40s. Really great tube, really hard to find and really expensive to get. The Telefunkens. They were driven by a pair of Western Electric 437. All the rectification was done also with tubes, 8 rectifiers per monoblock. That was a limited project. We built a limited number, and mostly these amplifiers were built for Cesaro acoustics.
So I understand you to be saying you will be releasing a new all-tube amplifier?
Yeah.
And will that be the single-ended or a parallel, say a parallel 211 or parallel?
Most probably a parallel single-ended.
Using the 211 or the GM70?
Yes, 211 GM70. There are a couple of other tubes that we are going to retest and recheck. Parallel single-ended, for there is a reason we are going for parallel single-ended. One tube normally is better. When you parallel 2 tubes straight, the sound gets harder and you are losing most of the magic of a single tube. Doing a separate power supply with separate bias for each tube and separate windings in the output transformer, so the DC path of each tube is separated from the other, you are not losing what you lose the other way. You have the opportunity to increase the load in each tube, so each tube is working more relaxed. And then what you get out of that is amazing.
Well, that's an exciting project. I'm glad I teased that out of you.
Yeah.
At Ypsilon, what turntable, tone arm, and cartridge do you use in your evaluation system?
The turntable is a turntable that a friend of mine built many years ago with a 60-kilo stainless steel and air-grade aluminum platter with inverted bearing. The tone arm is an SAT, and the cartridges are the Etna SL and my Sonic Labs, the top of the line.
And what loudspeakers do you use in that system?
The speakers are a pair of speakers we built in 2005, and it's based on, it's a 3-way speaker, 91 dB sensitive with custom audio technology drivers, woofer and mid-range, and ribbon tweeters that we built in-house.
In addition to the parallel SCT amplifier you're developing, what is the next update or next new product we should expect? Do you have any plans to update the phono stage or line stage in any way?
The phono stage is already updated to MK2 version. We have updated some details in the power supply, components that they didn't exist when we originally designed the phono stage, and also using different tubes. The original unit was using the Siemens C3G. The MK2 uses the Siemens EC8010, and at the input, a pen dot equivalent to E180F, a Rosen type, the 6ZH11.
Dimitris, this has been great. Thank you so much.
You're welcome. Thanks for giving me the opportunity.
My pleasure.